Hello and welcome to the Reversing Climate Change podcast. I'm Ross Kenyon. I'm the creative editor at Nori's Carbon Removal Marketplace. Today, I have back with me for the third time, Peter Brannen, author of The Ends of the World About Earth's Great Extinctions and writer of the new article in The Atlantic, The Terrifying Warning Lurking in the Earth's Ancient Rock Record. Welcome back, Peter.
Thank you. Thanks for having me.
Yeah, 3 times. It was a one bonus episode, and then we had one about your book, The Ends of the World. Is that right?
Yeah. I'm a regular guest at this point.
Yeah. Who are you trying to impress? Yeah. I really like your work. Whenever you or David Grinspoon come on, I always like thinking about deep time. I think it's underrepresented in science spaces and climate spaces overall. It makes me think, it makes me zoom out, and it really helps me understand how the world works over long stretches of time. Even to this date, reading your book, reading David Grinspoon's book, how come it's so hard for me to understand how old the planet is and how it works over the course of that much time?
I think it's because we are primates who evolved pretty recently and we live on decadal time spans. And just like it's impossible thinking about quantum mechanics, there's all sorts of mnemonics and stuff for thinking about how small and weird quantum mechanics are, how big distances in space are. We also are not evolved to think about geological timescales, which are just totally beyond the realm of the human experience. And so like geologists have ways of thinking about them, but they're all sort of, tricks of wrapping your mind around it, but you really can't. I don't think I can really intuitively grasp what 1,000 years is, much less 1,000,000 years or 100 million years or 1,000,000,000 years. So,
well, if you can, then I won't feel too bad.
Yeah.
So 6,000 years, you have agriculture and writing and Sumer and things like that. And 12,000 is the end of the last big ice age, or we're in like an interglacial period now.
Right.
But modern humans, anatomically modern humans, have been around for about 200,000 years, right?
Yeah, around there.
How come? So if we evolved to during that period, and we like came of age as a species during that time. But even 200,000 years is bonkers to me.
Yeah, and the changes you see on Earth over the span of our pretty short existence are pretty outrageous. The written word starts a few thousand years ago, but immediately before that, you drop into a massive ice age where it's 5 to 6 degrees colder, sea level's 400 feet lower, there's a half mile of ice on top of Boston, and there's all this giant megafauna all over the planet. We were in this other interglacial that was actually maybe a little bit warmer than today, 130,000 years ago, when sea level was 30 feet higher than it is now. But what's kind of frightening about paleoclimate history versus written history is that humanity and everything that we sort of give the catch-all term civilization has really just been in this almost bizarrely stable little window of climate history in the last few thousand years. And that because of our short sort of institutional memory as a species, we don't remember how kind of crazy this planet actually can be. And we've been through some stuff before with going in and out of ice ages, but I think in the next few decades, centuries, we're sort of going to be reminded as a species just how cantankerous the planet can be sometimes when you mess with the main knobs on the climate.
We're certainly going to dig into some of that even farther back history, but I'm hoping to be able to anchor us to start. And this is maybe selfish because I need to know this for my own purposes. So last 200,000 years, that's the Holocene.
No, the
Holocene's now.
The last 11,700. Yeah. The last 2.6 million years, the Pleistocene.
So then I've arbitrarily mapped on modern humans to this 200,000 number. That doesn't actually have a geological...
Yeah, right.
Okay.
Well, the Holocene is an extremely anthropocentric idea because the Holocene is just a run-of-the-mill interglacial, and there's been dozens of interglacials in the last 2.5 million years of the Ice Age.
How come anatomically modern humans, 200,000 years.
Yep.
The Holocene, what we're in now, is just an interglacial period within the Pleistocene, if you want to frame it that way.
Yeah.
How come civilization didn't grow during any of the other interglacial periods during that time?
Well, we've been through one as anatomically modern humans, but I have no idea. That's a question for, an archaeologist or an anthropologist. But I do think there's something to the fact that if you just look at sort of the temperatures in the last 6 or 8,000 years, it's sort of been like a flat line. And even within that, there have been very mild sort of events, completely geologically run-of-the-mill volcanic eruptions, changes in pressure systems on the planet that are, again, completely routine from a Earth system standpoint, but have, felled empires or breathed life into other empires and have dramatically affected human history. But essentially, all of recorded histories happen in a very peaceful span, even though things that look to us like as sort of big deals from a climate perspective are really sort of just what you'd expect on a tectonically active planet.
You overcomplicated it, Peter. The simple answer was Atlantis and
Yeah,
Graham
right.
Hancock and original super civilization.
Yeah, I do get those emails as well.
Oh, yeah. I almost want to cut this out of what I just said because I don't want to get those emails. They're out there, the alternative archaeologists. They're writing email.
Yeah, and they're usually in all caps, and they give you a lot to think about.
Egyptologists hate this man. Learn his one secret.
Right.
Yeah. Okay. Fair enough. Well, why don't we start talking about your article here, The Terrifying Warning Lurking in the Earth's Ancient Rock Record, that recently came out in The Atlantic. I loved it. Many Norinauts read it and were stimulated by it. Definitely makes me think. Give us a tour of the piece, Peter, without having to read it back verbatim, which
your
work is challenging like that. There's a lot of context that is necessary to explain sometimes.
Right. Well, the first part of the story is what I was just talking about, which is sort of laying out the context for human quote unquote civilization in the past few thousand years, the climate context, which can sound pretty eventful, but actually is not that big of a deal when you pull back further into geological time, because we're actually just in this stable period of a interglacial. And if we weren't here, there's reason to believe that we might be going back into a glacial, if we weren't seriously disrupting the carbon cycle for not just the last couple hundred years, but possibly even thousands of years.
I feel like I've seen people say this too, especially people who are not big on climate change.
Right.
Prevented ourselves from going into an ice age.
Yeah. So you can pluck little parts of climate science out of context to try and make some political point, but we're not going into an ice age anytime soon. Probably not for hundreds of thousands of years because of our activity on the planet, especially putting lots and lots more greenhouse gases into the air. But for the last 2.5 million years, we've been going in and out of these really dramatic ice ages when CO2 has switched between about 280 and 180 parts per million. They're pretty complicated. They have to do with the planet's orbit and how much sunlight is hitting northern latitude summers that can be explained by these big orbital changes that happen over tens of thousands of years. But feedbacks in the carbon cycle, well, those changes in sunlight happen very gradually, but the drops in and out of the ice ages are really sudden. So there's clearly some big feedbacks going on that make the planet a lot more dynamic than you would expect just if it was all from changes in the planet's orbit. But if you're learning about paleoclimate and you're learning about the most recent period in Earth history, it's actually sort of confusing because it gives you this impression that, it must be sort of sunlight and orbital stuff that can control the climate. But the only reason we're in an ice age at all is because CO2 is as low as it is. And the piece sort of goes beyond the ice ages to when CO2 is higher and you escape the cycle of ice ages that we've been in. And as you go back 50 million years into the past, as you stop along the way, and this is sort of what I do in the story, CO2 continues to go up and you reach sort of warmer and scarier analogs for potential warming in our own future. So the last time CO2 was at 400 parts per million like it is today, you have to go all the way back 3 million years. So you're out of the interglacial glacial cycle, and sea level is now 70 to 80 feet higher than it is today. And this is an incredibly long time ago. This is before, obviously, the evolution of Homo sapiens. And the planet's a lot greener and wetter. And there might be this weird thing going on where El Nino seems to be a more permanent feature of the planet. It's 10 to 15 degrees warmer in the Arctic, and you have giant camels and beavers living up there in evergreen forests that go right to basically to the North Pole.
Wait, just to anchor this real quick, Peter, you said it's, what was the ppm of CO2?
Around 400 parts per million. So what we have today. So if we kept CO2 at 400 parts per million, this time period called the Pliocene sort of shows you where the planet would be happy in the long term, getting to equilibrium. So perhaps almost no ice on Greenland. Maybe the West Antarctic ice sheet has collapsed. The good news for us is that we can temporarily overshoot CO2, really temporarily. And if we bring it back down again, maybe we'll avoid this. But these paleoclimate analogs sort of show you something of a picture of what the planet would be at equilibrium in a 400 parts per million world. And as you go further back, the analogies just get crazier and crazier until you're in the Eocene and there's crocodiles in the Arctic.
Are crocodiles in the Arctic crazier than giant beavers? It's hard for me to weigh these against each other. But so,
Well, yeah,
I mean,
sorry.
people always single this out too as being like the lag in the system, or how come 400 parts per million in the past led to certain climatic conditions. Why is that not visible now? Do you have a
Yeah.
easily digestible reason why that is?
It's just that, things like ice melting, it can take a long time, and replacing that with forests and changing the planet's albedo can take a very long time. But in the interim, as the planet's sort of straining to get to that new point, things will be pretty wild and chaotic. The Greenland doesn't really like having half of an ice sheet. It likes to either not have much of one at all or having a big one. And so, I think there's this idea that as CO2 goes up, sort of the effects will just be linear, sort of will scale with that. But the paleoclimate record sort of shows that the planet sort of makes more like stepwise changes, these jumps between states that it likes being at, rather than, just this linear progression of ice melt or sort of things like that.
Most of the discourse that I've seen, and this might be a failure of my interpretation rather than how it's being presented, but is linear change, especially with the like average global temperature
Yeah.
to stay under 1.5 or 2 degrees Celsius.
Right.
It makes it sound like, well, obviously the earlier we act, the less dramatic the changes are, but it doesn't sound like at some point going from 2 degrees to 2.5 degrees is logarithmically different than the previous degrees. But it is
Yeah.
potentially at some point.
Yeah. Well, a lot of these things also end at 2100.
Uh-huh.
And the stuff I'm talking about are sort of long-term feedbacks over thousands of years, which even thousands of years geologically is nothing, but on human timescales, it's a lot. And so sometimes people ask, well, why should we care about what the world's like when I'm not around or something like that? And my favorite way someone's addressed this is David Archer, who wrote The Long Thaw. He's a University of Chicago geologist, and he put it in terms of, well, imagine if the ancient Greeks or someone had discovered fossil fuels and we were living in the world that they created. We were all up in the Canadian Arctic and rainforests and things like that. We're in a period of human history where the next few decades, we're really going to chart the trajectory of human history for thousands and thousands of years. So maybe that wouldn't impel you to become a climate activist, but I at least think it's fascinating from a sort of humanistic perspective.
Oh yeah. And I love those wild historical counterfactuals too, of the Greeks having the steam engine but not figuring out how to connect it to a sort of like locomotive device.
Yeah.
Being like, isn't this a cool toy? It spins around really fast. Like,
Yeah.
wow, they were really close, huh?
Yeah.
Okay. Keep walking us through your piece. Sorry, I keep interjecting here.
Yeah. Well, so I talk about the Pliocene, and then the next one back is the Miocene, which is, so there's this thing called the mid-Miocene climatic optimum, which is about 16.5 million years ago, which at the beginning of the piece, I'm moving at 1,000-year time scale, and now I'm making jumps 10 million years into the past. And so the planet is really, really different, even if you saw it from space. The Mediterranean would have sort of spilled out into the Indian Ocean. The Central Valley of California would have been ocean. Panama would not be connected to North and South America, wouldn't be connected. So animals that we sort of think of as iconic in South America wouldn't be there yet. So what things like llamas and big cats and tapirs and things.
Those were North American originally?
Yeah. And then in the Pliocene, actually, you get the Panama connection and they take over South American fauna, and the camels went extinct in North America, but they evolved here. In fact, they might have even evolved in the super warm Arctic that I was talking about before. But in the Miocene, you're way past that. In the Miocene, the Amazon is running backwards and it's sort of spilling out into northern South America, and the Andes aren't that big and the Rockies aren't that big. But this is the last time CO2 was 500 parts per million. So this is sort of an intermediate level of something we could do in the future. And 500 parts per million back then means that you have sort of swamps in Greenland, and there's this island in Canada. Canada would have sort of looked like the Midwest flora. And the reason why CO2 is 500 parts per million is because you have this thing called the large igneous province, which I talk about a lot in my book because they're responsible for some of the biggest mass extinctions ever.
It's like the Siberian traps and stuff
yeah. So the Siberian traps is this massive one that covers most of Siberia. But there are these once in a few tens of millions of years events where the continents or even ocean crust can sort of turn inside out and release millions of cubic kilometers of lava, but they also inject a lot of CO2 into the air. And in the middle Miocene, you have this large igneous province in the Pacific Northwest that makes up a lot of the basalt canyons that you see there now today that people love kiteboarding through.
Like Columbia River?
So it's called the Columbia River Basalt is the name of this group of volcanic rocks. And it dates basically exactly to the time of this warming up period in the Miocene. So it's thought that the CO2 from these volcanoes made it about 500 parts per million. And the temperature might have gone up to something between 4 to 8 degrees warmer than it is today, Celsius. So that's really warm. There's no ice in Greenland, presumably. Sea level is 157 feet, I think, higher than it is today. So if you plot that onto modern coastlines, it would just most coastal cities, obviously. And Antarctica seems really sensitive to small changes in CO2 in the Miocene in ways that we don't really understand. There are some mechanisms that people have proposed, these really scary things called marine ice cliff instability, where, again, it's not really this linear thing where ice sort of melts like an ice cube, but it just starts sort of collapsing and things fall over like dominoes. And maybe that's how you get sea level so high back then.
Oh, that's unique to Antarctica, though?
I think so. I think that's how people have proposed to explain the really high seas in this period, but also other ones. And it's something that we don't know whether it's going to be sort of set in motion in our own time. So it's a very active area of research. But generally, we've had trouble for a long time explaining why both the planet is as warm as it is and why sea level is as high as it is. So that's what's sort of worrying is like we have models that are catching up and doing a really good job, but you kind of have to check them against what's actually happened because the only experimental record we have of climate change is sort of what has happened on this planet. So it's probably not the fossil record that's wrong. It's probably something in the models that we're not quite capturing.
I imagine climate modelers probably do look for historical analogs in design. Do they use it to calibrate?
Yeah, totally. Yeah. And this is why I've been saying that they've been getting better at this because for a long time, it was just they would, for the Eocene, this period that I'm going to talk about, which is sort of the next one, the worst case scenario when there's crocodiles in the Arctic. I talked to this paleontologist who she would find these crocodile bones in the Arctic and she would tell climate modelers about them. They would say, well, can you put hair on those crocodiles because they shouldn't be there? And, they were joking, but sort of the implication is that, well, our models are right and your fossils are wrong. But it's probably the case that the fossils are right. But with the latest generation of climate models, it's actually too sensitive. So that's one of the reasons we know why. There were some headlines last year about CMIP6, which is sort of the latest generation of global climate models. And
I missed this then.
Yeah, it was saying some really scary stuff about how a doubling of CO2 would be something like 6 degrees C. And it was scaring some people, but when they compared it to paleoclimate, it was actually too sensitive. So there's sort of becoming a more interdisciplinary approach to these things where the modelers and the paleoclimate people are talking to each other, which is good. We're getting a better idea of what happens when you turn the CO2 knob.
Okay. I'm extremely sensitive, Peter, to baffling our audience since it's hard for me to wrap my head around this. Why don't we review a little bit about the two eras that you're discussing, and then we'll go into the third one. So the first one we discussed, it's at 400 parts per million CO2 in the atmosphere?
That's the Pliocene. That's about 70 feet of sea level rise.
Okay.
And the evergreen forest in the Arctic with giant camels in them.
And there's giant beavers too?
Yeah. And another interesting thing is it's really wet in the subtropics. Another sort of disagreement between, or longstanding, but again, beginning to be resolved, disagreement between models and paleoclimate is there's this idea that the wet parts of the world are going to get wetter and the dry parts are going to get drier. And the Pliocene looks like just a really pretty wet place. And that seems to be true as you go further and further back. The planet sort of gets more forested and jungly. And it might have to do with large scale changes in atmospheric circulation that, again, we shouldn't expect anytime soon, but that might be the sort of the happy place for the planet to get to with sort of a more sluggish circulation of the atmosphere and sort of just a uniformly more wetter planet. But in the near future, the drier gets drier thing is probably accurate and the wet gets wetter is probably more accurate.
Okay. So then this first stage you talked about, Pliocene, sea levels are 70 to 80 feet higher. The world overall is wetter.
Yeah, some people would disagree with that, but I mean, you do see the Mojave is wet and the Atacama is wet and there's woodlands in the middle of the outback. And so it does seem like a slightly wetter world.
If the Atacama is wet, then the planet's probably wet. Wow. Okay, so then what about this second one you've already told us about?
The second one is 500 parts per million, or the temperature's about 4 to 8 degrees warmer. There's parrots and turtles in Siberia, and there's swamps in Iceland, and we're so far back that most of the animals wouldn't really be familiar to us. They'd be mammals, but they all would sort of look like funhouse versions of things that we're familiar with. It's 4 to 8 degrees warmer, and I think there's kind of a risk in looking at a world like this and being like, well, a foresty planet at 4 to 8 degrees warmer doesn't actually sound that bad.
Plants need CO2, right?
Yeah, but it is a dramatically different flora and fauna distribution than what we're used to. And we shouldn't expect that if we make the sorts of changes that we're making, that life will be able to sort of establish itself like that. Like, this was a planet that was slowly evolved over millions of years on a greenhouse world. And to suddenly launch the planet into a state like this in a couple centuries, it might be too fast sort of for life to adapt. That's the second one, the Miocene.
At least for us, right? I think the Earth will be fine. Life finds a way. It'll figure it out.
I don't know. So
really? Wow. That bad?
Certain species will definitely. So, I mean, birds with big ranges and fishes and things like that might be able to adapt. But there are organisms on the planet today that are still trying to catch up with the thaw of the last ice age. So there's lodgepole pine, I think, in Yukon territory that's still marching north to try and reclaim areas that were recently covered in an ice sheet thousands of years ago.
Wow.
And so life has sort of been going up and down in response to glaciations and interglacials, but suddenly launching it into this world, this vanished world from 16 million years ago, is sort of asking a lot for life to try and keep up with. And then the last paleoclimate analog I talk about in the story is the Eocene, which is sort of like RCP 8.5 Bernoulli worst case scenario for our future. Where
the what?
RCP 8.5, it's like the highest emission scenario for humans in the future.
Uh-huh.
And it brings you to about almost 1,000 parts per million of CO2 by the end of the century.
God, what would have to happen for that?
I feel like there would have to be like some sort of, well, one scary possibility is that carbon cycle feedbacks are not modeled very well. And even if we take an intermediate emission scenario, there could be emissions from land clearance and permafrost and stuff that gets you to RCP 0.5 anyways, which is really scary.
Wow.
But the other possibility is, I don't know, like societal breakdown and everyone goes back to using coal and things are pretty bad anyway. So worrying about paleoclimate analogs is... Dude,
the steampunk century. We're going for it.
Yeah, but the scary thing about the Eocene is the highest CO2 analog I look at is some studies by looking at fossil leaves say that CO2 is only around 600 parts per million, which is not that high. And this is the sort of the time period I'm talking about when you have things that look like rainforests in the Arctic. So in the previous sort of analogies, it's been temperate to cold biomes living in the Arctic. And this is like have things that look like hippopotamuses and alligators and giant salamanders and little lemur type things, all living on Ellesmere Island in Canada, which is basically the furthest north island in Canada in the Canadian Arctic. It's the last land you step foot on before you hit the North Pole. And there are fossil jungles basically eroding out of the landscape. And the CO2 was somewhere between 600 parts per million and just over 1,000, which is definitely achievable by humans. And that is a completely alien world. So these are basically rainforests that are enduring 4 months of Arctic night. There's just no modern analog to an ecosystem like that. And there's definitely no guarantee that something like that would be able to establish itself if humans carry out climate change on that scale in the matter of a few centuries. So the Eocene is kind of the scariest thing in the story, but I also think we're probably not going to get that crazy. This is another area where models and sort of the fossil record have not matched up for forever, basically, until really recently. We used to have to jack up CO2 in climate models to over 4,000 parts per million to get it that warm. But now models are incorporating sort of really complicated cloud physics. So it might be the case that clouds in the mid-latitudes kind of disappear once you pass the CO2 threshold and you invite a lot more sort of sunlight energy to warm the oceans. And maybe that's why the Eocene was as hot as it was. But it's something that we're still definitely, like, the models are trying to play catch up with the fossil record to try and reproduce why it was exactly as hot as it was.
So I made an assumption about how catastrophes are responded to within geological deep time. And my assumption to date has been that the Earth moves on and hundreds of thousands or millions of years, new life figures out how to make things work and moves on.
Yeah.
Do you actually think that it no longer holds potentially for a radically human altered climate in the future?
No, I think that is definitely the case. I just think that hundreds of thousands of years is such an irrelevant timescale for humans that saying that it's all going to be fine in a million years is probably true, but kind of who cares?
Yeah. It's got like a little bit of the whiff of the, besides that, Mrs. Lincoln, how did you enjoy the play?
Right.
Kind of vibe to it.
Yeah. And I do think there's things that have happened in Earth history that are way worse than we could ever be. So like the end Permian mass extinction, which I write about in my book. These volcanoes went off in Russia that might have injected something like 100,000 gigatons of CO2 into the air, which is so far beyond what humans could ever do. It was over thousands of years, but it's still super extreme. But on the other hand, doing something like launching ourselves out of a glacial, interglacial climate that it's been for 3 million years into a greenhouse sort of dinosaurish world, as far as I know, and there was a paper written about this by Jan Zalasowicz, who's a paleontologist at the University of Leeds, but he basically sort of looks at the fossil record, and the only analogy he can find for switching from a glacial state to a greenhouse state is in the first major mass extinction of all time, this thing called the end Ordovician. So, if you see an economist telling you what it would be like for a planet to go like 6 degrees warmer than it is today, something that maybe hasn't happened for 445 million years, I think you should take that with a grain of salt, because that you're really launching into uncharted territory there.
Are you seeing that? Are economists out there talking about this?
I don't know. Sometimes you just see graphs of like very, very confidently plotted things about this was what happens to GDP if it gets this much warmer. And it's like, you're talking about things that have hardly ever happened in geological history. I think making extrapolations about how human society would respond to them is a little crazy.
Yeah, fair enough. I mean, that's partly what William Nordhaus won the Nobel for economics, right?
Yeah. I think he said the ideal level of warming is like 3 to 4 degrees warmer or something, which strikes me as completely crazy. But what do I know? I don't have any Nobel Prizes.
Yeah. Watch yourself, Peter. I haven't read that research, so I'm hesitant to speak too much without knowing it hardly at all. But I think some of those claims get seized upon with a level of confidence that is maybe a bit too optimistic.
Yeah.
Especially once it's 3 to 4 degrees also just doesn't sound that bad. You say, oh, if we get richer over the century, adaptation is going to be pretty affordable. It's a small percentage of GDP globally. Let's just do it. It's better than shutting down industry. And are you just screaming, pointing to deep time, saying, I don't know.
Yeah, no, I mean, that was kind of a motivation for the story, is that 3 to 4 degrees doesn't sound like that big of a deal. And you can really only appreciate what it means and how unprecedented it would be by looking at deep time and understanding just what that was like 3 to 4 degrees warmer. It's a much different world. And it's one that humans did not evolve in. There's, good reason to believe that a lot of the things alive on Earth today were sort of shaped and molded by these glacial, interglacial swings. And once you sort of leave the regime of that world, you're going into a world where the stuff, life on Earth today wasn't really evolved. So for instance, like whales, there's an idea that whales are as massive as they are today, basically as an adaptation for the ice ages. And before 3 million years ago, you have all these crazy little whales and things that were pretty residential and didn't span the earth with huge blubber stores looking for food in these uncertain ice ages. And so really, just from an evolutionary standpoint, it's kind of amazing that in a few decades, centuries, we could reproduce that world. But I also think that reading this, and when you don't keep sort of the geological timescale in mind, it can come off as maybe more scary than I intended, because we do still have time to sort of head off all of these things. Even the Pliocene, which was the same CO2 as today, there's no reason why sea level has to go up 70 feet, because there is sort of a lag. We have a chance to overshoot it, which we should not really take seriously at all. We don't really have any budget left to blow. But I don't want to inspire people to just be sort of resigned or fatalistic by reading my story, but to show sort of how much we've already done and how big the task is to sort of avoid these paleo futures, I guess.
I know that there are lags in the system, but is there some general sense of what ppm we would have to reach to break out of the glacial interglacial cycle?
So Jess Tierney, who I talked to for my story, she recently tweeted about this. So there's this idea that 350 is the right spot, 350 parts per million. Bill McKibben has 350.org, and there's this idea that once we surpass that, suddenly we were in this unnatural, non-Holocene sort of state. But Jess Tierney argues that 350 is too high because
280 is what we started at, right? Yeah.
So 280 brings you back to the normal, like sort of the normal interglacial CO2 of the Pleistocene, and we're already 130 parts per million above that. So in the long term, we probably want to get it a little lower. And if we're a really smart species and we can start thinking on 10,000 year timescales, it is true that we don't want CO2 to go too low because we don't want to go back into an ice age, but that's something we don't have to worry about for a very long time. And given our sort of maturity as a species, I don't think it's going to be, we're going to be adept enough to sort of manage the planet that well anytime soon. So in the short time span, we need to figure out how to stop erupting CO2 into the atmosphere at the rate we're doing, and probably even bringing it down even below where it is today, if we want to sort of stay within the climate window for which we and most other life on the planet sort of evolved. So,
did I miss it though? At what point do we break out of that cycle? Is there a number you're comfortable giving, or is this not appropriate?
Anything above 300 sort of outside of the Pleistocene window, I'm pretty sure.
Oh, okay. Wow.
Yeah, because the Pliocene is, which you finally escape the Pleistocene, is like 350 to 400 or something like that.
Wow. Okay. So if you take that sort of longer, deep time perspective, then the carbon budget is deeply blown at this point.
Kind of. But, if we have this miracle with carbon capture, it could potentially bring it back down. But again, these would be changed. The sea level changes and the albedo changes would be things you'd expect to see on the order of thousands of years, hundreds to thousands of years. So we have time, I guess. Although there are runaway processes, so some of these ice processes might kind of be runaway. And there was even a paper about Greenland recently that suggested that something like that had already started.
Yeah, those positive feedback loops are real spooky once they start. I don't know how you break them.
Yeah.
But okay, so your article, if someone wants to go back and read this, and I imagine if they like this article, if you like this article, you'll like Peter's book too, which is very good, The Ends of the World. I'm going to be obsequious for 10 seconds. How do you know all this information? You'll just be like, oh yeah, the Pliocene, yeah, it was like this. Yeah, then the Eocene, ooh. The Antarctica was up by Spain at that time.
That's mostly from having to go back and forth with a fact checker for like 2 weeks on all the facts in the story. But I would say writing the book, I sort of wrote a book proposal that said, hey, I can write the story about the last 500 million years. And then I found out as soon as it was time to do it, wow, I have a lot to learn. So I kind of feel like I had this crash course in all of Earth history writing the book. And then I was lucky enough recently in 2018 and 2019 to do this fellowship at the University of Colorado called the Scripps Fellowship. That's for science journalists. If there's any science journalists or environmental journalists listening, I would really encourage them to apply to it. But it gave me the chance to basically just audit courses and meet with professors and interview people for a year. And I really got a good grounding for a lot of the stuff I write about now. And it not only helped me write this story, but also write a book that I'm writing right now that hopefully will come out some year in the future.
I'm certain, if circumstances allow, we will love to have you back on to talk about it. What is the new book? What is it about?
It is about the carbon cycle over all of Earth history. And I guess the little elevator pitch would be that we think of CO2 as just this kind of random industrial byproduct that happens to come out of smokestacks, but you actually can tell sort of the whole story of the planet, the origin of life, behavior of the climate, the habitability of the planet, the big mass extinctions, human civilization, and the Industrial Revolution. And basically everything can sort of be told through the lens of carbon dioxide and carbon, because we are a carbon-based species and we live on a planet where the climate is basically regulated by carbon, and it's a carbon planet. And I'm going to try and tell that sort of big story.
If you really want to sell well, Peter, you should go for the middle brow classic of something, how carbon dioxide can change your life in the periodic climate. That's how you sell books.
Yeah.
On you. Is there any risk of over focusing on carbon or carbon dioxide in telling Earth history? How do you balance that, or is my concern overblown?
No, I don't think there is. It could be the case that in some of these really warm paleoclimates, there were things that we don't understand about other cycles, like nitrogen cycle and maybe methane cycle, which is carbon as well. But There is a paper in Science, the journal Science, that says CO2 is the primary knob of Earth's temperature, basically. And one of the founders of modern climate science, Wally Broker, wrote a textbook called CO2, Earth's Primary Climate Driver, I think was the name of it. So I feel like the more we learn, the more central we understand this knob that we're turning to be. That CO2 really does explain most of the variation in temperature over the entire history of animal life. The reason why the planet wasn't frozen solid earlier in its Earth history was because the atmosphere had lots more CO2. Plants are made out of CO2, and we eat plants. We're ultimately made out of volcanic CO2. So this really is, at least in my mind, the central player on our planet is CO2 and how it behaves in Earth's crust, oceans, atmosphere, and through life. So I'm going to try and tell that story. But I do understand that concern, and it's one that I sort of shared as well. I was like, there's no way that this gas really is that important, is it? And I really think it is.
Okay. It's good to hear at least you're thinking about that. I'm sure this is an active debate and has been for a long time. But yeah, I worry whenever the one great explanatory variable that determines everything. That should, anyone who says that should make you suspicious, right?
Yes. But I feel like I've been suspicious for long enough that I'm now comfortable.
Yeah.
But humans do weird stuff. Like we put nitrous oxide is a powerful greenhouse gas, and we have to worry about that. And so there are other things that we have to be concerned about, but CO2 is a massive one.
Cool. Is there anything that we didn't cover about this piece that you'd like to talk about before we move on?
I don't know. I feel like I've been rambling and speaking very fast, so I hope it made sense.
I think it made sense. These episodes are the hardest for me as the presenter or host to try to make sure that a listener has enough context that doesn't just wash over them. Be like, yes, that epoch. Right. Yes, so interesting.
Probably why my story was 8,000 words, and the first draft was 15,000 words. It's because it's hard to set the scene, because we learn about I remember in high school learning about American history, and it seemed like the world sort of started a couple hundred years ago, and you don't ever really learn our context in a deeper time sense. And I think that's what I'm trying to do with a lot of my work.
That makes sense to me. And we spoke about this a little bit before we started recording, but in your work, it sounds like, especially if you had to cut down the word count that much, that you started telling a story and then realized to tell the story that you needed to tell, it required a lot more space and zooming out even further than you already were. Is this just the persistent challenge of your writing? Yeah.
And so in my next book, I'm going to try and basically capture everything I can possibly write about.
All 1,300 pages are only $79.99 plus shipping and handling.
When you pull one thread on this, I made a conscious decision to include a lot of human history in this latest story. Because I think there's this unnecessary division between natural and human history and sort of science and the humanities. And I think that's starting to be broken down, but it's something that I'm very conscious about sort of trying to bring down myself, because I think sort of sometimes science stories or climate stories are seen as, well, here's the serious part of the newspaper where we talk about important cultural issues. And then there's the wonky science stuff. And I just think that that wall should not exist at all. And we are part now, as a global industrial civilization, we are now a cog in the global carbon cycle, and we can't really understand what we're doing on the planet if we don't understand the geochemistry and sort of our context and our history. So I guess that's something I'm trying to do.
I think you're pretty successful at it, and I think it's a noble mission. Science communication, translation. I don't even know that my science literacy is very good, despite working in fields that are either within science or adjacent to it. These topics are big and important, but it certainly is a lot easier to ignore it, zoom out, focus on something else that's a little bit more accessible to our lived experience.
Yeah.
I would not count anything related to this as lived experience. So it makes it all the more important to bring it into that, so it is accessible, interactable in a way that I don't know, can make sense of. Really, the way that I think about this is I almost think about my science learning as geological, of building up these new layers in the stratigraphy of my knowledge. I'm just like, okay.
Yeah, right.
And like I keep going over it and keep adding, but it's still, I feel like I'm drowning in information sometimes. Your writing though, I think is like a branch I can grab and pull myself a tiny bit.
Well, I appreciate it.
Yeah. Links to Peter's latest article in The Atlantic is in the show notes, the link there. Also, go buy Peter's book if you haven't before, The Ends of the World. I learned a lot. It's been super influential for how I think. It's a great introductory book for geology and earth science, earth history. Well, thanks for being here, Peter.
Yeah, thanks for having me.
Well, thank you so much for listening. If you like the show, please rate and review it in Apple Podcasts and/or Stitcher. It really helps us a lot to get this content to a wider audience. If you think what we're doing is useful, interesting, fun, hopefully all three, we'd certainly appreciate your rating and review. You can keep up with Nori at nori.com, where there is a newsletter. That's nori.com/subscribe. There's podcasts. There's a whole bunch else. Or you can send us an email at podcast@nori.com. We are also now on Patreon at patreon.com/noripodcasts if you'd like more content, engagement, and community. And thank you so much for your support.